now, we are going to be having 2 hour sessions. I'll be taking the 2 of them. And the first one, I just want us to lay our hands on model simulation R. Before now, we have been coming up with models, and we have been seeing how to write the model equation, to formulate model equations. A lot of analysis have been going on up to this morning, when we had to even look at sensitivity analysis. But sometimes it will be good we look at how to run simulations, how to bring the model that we have into R. So this afternoon, the goal here is to just do something simple that you can build on. After now, many of us in our various groups would have to run some simulations on our model, and it will be good that you have the skill to do that. So please, let's pay attention to every step of the way, and then I believe that after now, in our groups, we'll now be able to do some model simulation. All right, so model simulation is a powerful tool for understanding complex systems, and for us, one of the things that model simulation can help us to do is to explore scenarios. That is, we can use model simulation to analyze how system responds to different input values. That is, different initial conditions and different parameter values. Now, when you have come up with your model, that's just a general, you have just written something general, right? It's a general model, general set of system of equations that you are creating. Now, for us to solve it, you know that if you have a differential equation, a linear differential equation, you can solve it analytically, right? But you know, as you begin to have systems of linear ordinary differential equations, and then particularly at you are having non-linear components. If you now have non-linear components, it becomes a bit more difficult to solve analytically. Then we may have to employ some of our numerical tools to solve it, and R can really help us a great deal to do that. R can help us a great deal to do that. So you can now see from using the model simulation, you can see how, okay, if different parameter values are coming in, what is the solution going to look like? If we are having different initial conditions, how will the solution look like? So that's very important for us, because any other thing that you have to do, even there are other situations that you want to just assess scenarios. You have interventions, for instance, and you want to see, okay, if we use this level of intervention, what is the situation going to be like with prevalence of this disease? What is the situation going to be like with incidence of the disease that you are dealing with? Now, I am not going to be speaking with any disease in particular. I'm just going to be using a general example. So meaning that, because all that is important is that once you have formulated your model, so how do I bring it into R? How do I run my simulations? How do I test scenarios? Is that okay? All right, thank you. Now, so I will be looking at an example which by now we are already familiar with. This is a very simple SIR model, and you agree with me that This is SIR model without demography, right? Yeah. So no matter how simple or complex the model may be, the same process that I'm going to teach now is the same process that is applicable to all. So, you know, those days in primary school when teachers give you something to do and then they now give you exercise, you say, no, you solve the simple one and he gave us the difficult one. So it's just, don't worry, even though I'm solving the simple one, but the process is the same, right? I'm bringing in the simple one so that we can type the code on time, not because we have to run away from the complex. No, we have to buy time. Do you get that? So the process is the same, either simple or complex. The model is the same. So we have this example where we have this epidemic model, very simple one, and then this time around we are not specifying general initial condition again. We are specifying specific initial conditions where we are saying that at initial time the susceptible people are how many? 762. And then at initial time the infectious individuals are how many? And how many people have recovered? 0. All right. And then we are also specifying the parameter values to be what? Beta as what? And then gamma as what? 0.6. Okay, thank you. So now we have this before us. So how do we bring this into R? Okay, I'm obstructing the board. All right, let me quickly call your attention to something. You will notice that this one has over n, right? Sorry, I think I made a mistake, but there's no problem. We'll go on with it. So in the code, I didn't specify over n, right? So imagine that there's no over n there. If it's over n, it's the same thing we'll say. Just type over n there in the code. Is that okay? So there's no problem in this. All right. It's something that can also quickly adjust. Maybe I will just adjust it in the code directly. So now the first thing to do is to bring in your model. Remember that I told you that in R there are functions, right? Inbuilt functions. And you can as well by yourself declare your own functions depending on what you want to do. For instance, as mathematicians, you'll be dealing with different kind of functions, right? So this one is a kind of function, specified function now, user-defined function that we are going to put in now. It's a system of ordinary differential equations. Are we together? And you know that in our system of ordinary differential equations, we have variables and we have parameters, right? And we also have the time. You remember, right? We have time, we have state variables, and we also have what? Parameters. So our model necessarily depends on these three things. Depends on what? Time, state variable, and what? And the parameter value. So we are coming up with a function, and I have decided to call that function closed SIR model. For some of you who likes to you can put your name there. At least be happy that I'm putting something for the first time. So you can put your name. If you are Shade, put Shade equals to, function. Just put Shade and declare it as this. So function. So we are putting function of T, state, and what? Params. Where T represents time, state represents state variables, and params represent what? Parameter. After this, then a curly bracket comes. Is that okay? A curly bracket. So then after the curly bracket, now there are different ways we can actually write this code, but I've decided to choose this one because it's a very simple way of writing the code. When we are using width as dot list, It's a very simple way of coding this system of differential equation. There are other ways, like I said, this is the simplest way. Okay, so what we are saying is that I want to bring in my state variable and the parameter variable. I want to bring them in at least, and I want whatever I put there to be used as the state variable, and whatever I put there to be used as the parameter, as the parameters. Are we together? So now, after that, you put comma, and then another curly bracket. Yes, open again. We are going to close all of them. So we go on now to our model ds. I'm just using that to represent the first line, right? ds is what? Minus beta times s times I. Don't forget, I told you the other that there was a mistake there, right? I could have just put over what? Over n. Now, if I'm going to use this over n, there is something I must have written here. Before that ds, I should have written n. I should have written n to be s plus I plus r, right? So wherever it sees this, it takes it as what? As n. Is that okay? Now, that's in a general situation. However, you know that the model we are having necessarily is a closed population, and are we together? And you know that it's a constant population as well. Is that okay? That is not changing over time. How do I know? How do you know when it's a constant population? If you do your you have your n as given like this, and you do the n dt, you will realize that it's equal to 0. If you do that, that is add up your right hand side, this for the state variable, because the n dt is necessarily going to be the s dt plus what? The I dt plus what? The r dt. And when you do when you add up, you know what the s dt is on the right hand side, you know what the I dt is on the right hand side, and the r dt on the right hand side is going to give you 0, right? And you know that when you have rates being 0, that means nothing, it's not changing, right? So to get n, you integrate 0, what are you going to get? Constant. Is that okay? So it's a constant value, meaning that if I know what my n is at beginning, for instance, n will just be what I have there in the s at the beginning, I at beginning, and r at beginning. Is that okay? That value that I gave you, s0, right? Plus I naught plus r naught. Is that okay? When you add it up, what are we going to have? 7 what? 760, 62. Is it 62 or 63? 63, right? So that value remain constant all through time. So you can as well just specify your n as what? 763. Is that okay? Let's check now. Plus I. S is what? I is what? What is S? So when you add it together, what are you going to have? 763 now. So you could also specify that. So meaning that the first line of code should, if I'm going to use that over n, so just to tell you that it's not difficult. So that means after, so I could have just said n is what? 763. So that my ds now becomes, what do I put as my ds? Minus beta, right? Times s times I over over n. Is that okay? Because if that's what I was going to put, are we together? Yeah, but that mistake is already there. So I'm just trying to say that even though the mistake was there, if I want to do it, I can still do it. Are we together? So, and that's exactly what I want us to do. And I'm happy that actually that mistake was made so that you can do something different. Now, can we run? So have you done that now? So now what is it? All right, we'll now do it together. Oh yeah, let's do it together. Let's do it together. Right? Okay, so I've just said that I could put what? N as what? N as what? 60 what? 3, and then now come here to do what? Over what? Okay, okay, no problem. And then this one also has what? Over N, right? Alright, so have you typed this? Have you typed this? Please let's be fast in typing. So like I told you, you could actually use your save it as different name. Are you there? So one way to check that you are correct and that the um, brackets are corresponding. When you place your cursor in front of the one bracket, it will indicate the corresponding bracket. You can see this is my own corresponding bracket, right? So place your own cursor there, it will show, it will highlight it. It will highlight the corresponding bracket for you. You do it, just place in front of it. It will highlight the correct. So if I put this one now, it highlights the corresponding bracket. So it helps me to trace which brackets I've been able to close and the one I've not been able to close. Because sometimes like this, when you have to use many brackets, you might make mistake not closing the one you have opened, and you run it and it throws error at you, and then you say, oh, I'm having error. So necessarily, if you do this, you have created a function called what? Closed.sir.model. You have created such function. And if you run it, you will see your global environment that should have taken care of that. You have put it there for you that there's a function called that. Right? So I will run it. So you see that in my console here, it's there already. And if I also go to my environment, I will see, but so that I will not disrupt some of you that are still typing. Or you should have finished typing this? Who is done typing? Okay. I've just told you that one good way to do this thing is just snap it, place it by your side and typing it. Are we good? Can we move on now? So don't forget that I've also taught you how to make comments. If I were you, I would make comments. Because the way you are typing in and it's running, you are happy. When you leave this school and you want to carry it and you are alone, you are the one who typed it. But you will forget that you are the originator. Because you will not be able to interact with the code again. Because you don't know what the code means. Right? You not remember what it means. So it's good that you make comments in front of what you are doing, right? What are you not seeing? What are you not seeing? So I've told you if you want to make comments, just put hash and write something in front of it. That will make you to remember what you are doing here. What are we doing here? What are we doing here? You can just say model, right? So this is the model. The next thing we will be putting will now be we need to supply the time, right? We need to supply the time frame for our simulation. Yes? What's line 3? 1, 2, 3. This one, right? Okay, starting with width, right? Oh, great. I have just told you that, for instance, if you have a formula, is that okay? You have a formula x squared plus 1. And you know that x is there. Is that okay? You are going to be making use of the value x later. So you can, and you know maybe the value x, you have 1, 2, 3, 4 that you want to test. You can say that width, then you put that formula. That means that it's going to use that formula to evaluate whatever value of x that you supply. Are we together? It's going to be giving you the, using that formula, evaluate the output of that formula with whatever value of x that you do what? Supply. So you are saying, with this formula, are we together? Do we get that now? So we are going to use that formula because this model now, we are going to use it later. Do you understand? So with this one, what the values of the parameters and the variables we'll be supplying later, it should help us find the numerical solution of this system that we have supplied to you. Is that okay? So you can use it to do, just to evaluate the either formula or equation that you have supplied inside. Do you understand? So the as.list, so it's going to be taking the state variable as list and params as list. We are going to see shortly, just we can. Type this one first. Now, this function we have said is a function of time, right? It's a function of state variable and it's a function of what? So I'm going to state all of them now, much more explicit. So let's go to now. Do you now see that I have my t here? Is that okay? Maybe, for instance, I want to simulate this outcome between 1 to 14 days. Do you understand? Are we together? Because I don't want to be typing, right? Okay, now let's please pay attention to this. Okay, so we want to specify our time depending on what duration of time you are looking at. For instance, maybe you are looking at, if your mood, you are talking about your time unit in days. So that means this will mean from day 1 to day what? Day 14, right? Now, one good thing you can do is that you can run this time. Just run this. Run this. And check what T is. What is T? The way I can highlight it and do Control Enter. Is that okay? I don't have to say T afresh. Just highlight and Control Enter. And then it will give you. So do you see your T now? Your T is from 1 to what? 1 to 14. So if I have specified something else, maybe from 1 to 120, are we together? Yeah. So it's going to so this is sequence, which later you are going to learn it more deeply in the next session, but then just use it for now. I want to specify integers from 1 to 14. So that just means it may mean in day, maybe 14 days, the first 14 days. Please show the slide. The first 14 days, or the first 14 months, or the first 14 years, depending on the unit of your time. Do you understand? Okay. So you have done that. Then we also do for parameter too, because every argument of that function must be clearly defined. The arguments there are the things that you have specified, the T, the state, and the params. All right, so I'll run that as well. It has saved it already. So it's because I have to minimize the console. That's why you are not seeing it. Are we there? What is it you can't see? All right. Then for the states, you know the state variables there, S, I, and R. You specify their values as well. So here I've used beta as 0.2, gamma as 0.2, or 0.6. So the question will be that, so how did you determine those parameter values? Yes. Now, when you are doing, if you are just running simulations, right? For instance, this one I'm not talking about any disease in particular. Let's say I'm talking about malaria now. So what's that beta represents? If it's maybe, I'm talking about biting rate, for instance. If it means biting rate, then I may have to go and look for the value of biting rates. Are we together? For the particular place that I'm working on, from either literature or other reports of studies that are carried out. So I have to consult literature to get those parameter values. For instance, now, you know that for malaria, if for instance I was looking at incubation, latent period of malaria, I think is between 9 to 18 days or so. So, and then you can take average of it. I've seen in some papers they use 10 days. Is that okay? So 10 days, and for you to get progression rate from E to I, that means you have to take 1/10. So then that's your, if you have used sigma for instance to represent that progression rate, that means sigma will now be 1/10 if you are working in days. So you largely have to look for some of these parameters from literature when you are doing simulation work. But if it is data work, there is something else we'll be doing later in this week called parameter estimation. Is that okay? Where you must necessarily estimate some parameters from data. But there are parameters you cannot necessarily estimate. For instance, if you are talking about demographic parameter, you don't estimate that. You get that from reports. For instance, in Nigeria, the National Population Commission, their website, if you go there, you will see documents giving information about demography. Across all the states in Nigeria, you can see it there. If I'm working on malaria, I want to get information on mosquito, I can go to CDC platform. I see a lot of information on demographic information of mosquito as well there. The natural death rate, how long do they stay, and all of that. So you must necessarily look up for some of these things in literature. And those that you cannot estimate, that you cannot, that you have to estimate then from data, we will later be seeing how to do that maybe before the week runs out. For now, we are assuming that we have all our parameters, specified. So that's the assumption here. Do we get? But because this one is not dealing with any disease, I'm not having any disease, I'm just trying my hands, laying my hands on how to run simulation. So these values are just hypothetical values. Do we get? Yes. But when I come down to a particular disease in mind, these values will not just be hypothetical. Okay? Now, having specified this, now I have combined two steps in one in this place. Originally, this first step, the highlighted one, see me highlight. Okay, sorry, this thing. Sorry about that. I didn't say you should run it now. I have not asked you to run it. Just speak. Just be calm. Let me see if I can extend it further. Okay. Yeah, so I was saying that I have combined two steps here. One from here to here, the highlighted one here, is a way of solving that model that I've specified numerically. Are we together? Numerically. And in R, we have a package called deSolve, right? Which I asked you to install the other time. So you must necessarily call that package now. So you should do it. So deSolve, you should install it now. Your system is just right in front of you. So install it. So If you have installed it, you should load it. For those that have installed it, load it. Why those that have not installed it, you install it. Install and load. Alright. Either you use install.packages, or if you don't mind, you can come here. Come to this place and click on install, and then it will immediately bring out something like this, and you put deSolve. If you have internet, it will have come up for me here if I have internet. So once you do that, you just install, click on install here, so it will install. But I'm not going to do that because it's installed. This one has installed it already. So are we together? Okay, so if you have installed that, so this, in that package, deSolve, right? Now, there is a function there that helps to solve our model numerically, and it's called ODE. Is that okay? Are we together? And many other ones there actually, but I'm fond of using this ODE. You can see other things that deSolve can do by checking the documentation. I've taught you how to check documentation, but I'm not going to do it because that is not my interest. So you can check the document. If you run this now, it will show you the documentation of deSolve and various things that you can do with the package. Is that okay? Yeah, but for now I am going somewhere specifically, so I will not want to be branching into those places because of my time. So this ODE is a function there, and if you type ODE after you have loaded something, you have loaded this. Are we together? After you have loaded your deSolve, so the ODE takes in some arguments. The first one here, y, which is supposed to represent the state variable. Is that okay? So what did we use as our state variable? What did we put it to be? State, right? I'll just say y is what? State. The second one talks about times. What did I use to represent that? C, right? And the other one is function, func, and that is talking about the model, what you use to save your model. How did we save it? Close.sir.model. And the last thing there is params, at least the most basic ones. Params. So what did I use to save the parameter? Params. Don't make mistake. This one is params, right? So I'm saying you should read params. You should read it as what? Params. So I've specified all that this thing needs to work with. I've specified it. Is that okay? But to tell you cannot find ODE or you cannot find any, if you have not loaded deSolve as package, is that okay? All right. It seems I'm having some error message here. Great. All right. Yeah, fine. Sorry, let me just. Okay. It's wrong here now. Please, Dr. Office, my laptop. Let me have my laptop. Okay, so let me allow you to type while I am sorting that one out for now. Oh, Yes. Yes, that's the code. Oh, from beginning, okay. Why I'm sorting that out, you can keep on typing the other one. Ah, media, please show them the code. Don't worry, don't worry now. I said just type the code first now. What's it? I'm not getting it. All right, thank you so much. I wasn't seeing that initially. Okay, yeah. So you know that when we started, I told you that if you have different, please let's do together. You can combine um, different numbers or different what we call vectors as one. Is that okay? We needed to bring these states and parameter values together as one with this C. Do you get? So, but I didn't put that C there to combine them. So now run it. See now. Am I not? Is it not displaying there? See the line that I'm putting cursor on. Width as dot list, right? Open bracket, isn't it? Then C to concatenate them. Is that okay? Then states and params, you close that and then you close this. Is that okay? So when you do that, so run this, run this, run this, run this. Just run everything now. What is the problem? You should not have anything called error again. Please, ICAMMDA team, can you join these people to check what they are doing? Check what they are doing. Have you gotten the codes? Please check what they are doing. So this is the time why this one is a parameter values. Don't forget to put everything necessary. Then this is the initial condition. Are we together? This is the model solution. So I will stay on this. So please help them to who is still having error. If you are having error, please let people locate you. Put up your hand, the camera, please, people are having error here. But try as much as possible. Look at the code very well. Look at the code. But if you are not having error, let me see your hand. If you are not having error, let me see your hand. Good. So I'm having some people. Right? Are we there? I have told you, you must monitor the brackets. Sure that your brackets are closed. You have opened some brackets, you have to be sure that they are all closed. And I've told you how to monitor it. Just put the cursor at the end of it and see if it is corresponding to the one before. If it's not having anyone that is corresponding to that, means you have opened a bracket that you have not closed. Or if you have closed more than you are supposed, you have added more than you are supposed to have, it's supposed to underline, give a very small red underline, underline with a red line. Are you there? Gamma times I, not gamma I. If you put gamma I, do not see it. And you know what your multiplication sign is. That's the star. Asterisk. How many of you are still having error? Some people are still having error. Some, the numbers are reducing. How you solve it is how I've been explaining. That shouldn't be a problem. Either you use T or you use time. You just have to be consistent. If I have used time also, I have to be consistent. All right. Can we move now? Who is saying no? Let me see your hand if you are saying no. The hands are not so many. Now, the people will sort you out. If we must stay here, we will not move. They will sort you out. Don't worry. That's why I would love that when I'm explaining, you honestly listen to me. All these things I was talking about them. I told you that now let's be together. Any function in R, any function in R has what we call arguments that it takes. Is that okay? If you have inbuilt functions, there are arguments it takes. If you have user-defined function, like we did today, you have defined a function, you have specified a function, close.ser. You have specified a function. There are also arguments too that you have specified. And I kept on emphasizing on those things. One is what? T. The other is what? State. The other is what? Is params, right? Now, ODE, which is a function in deSolve package that helps us to solve the model numerically, also takes in some arguments. Those arguments are the things that I mentioned. One, it takes in y. What does y mean? It means a state variable as you define. So that's why I said y equals what? States, right? It takes in times. What's your times? Is that your time? So the times equals to what? The time that you define. If you have used t or you have used time to define it, put it there. Is that okay? Then it takes in func, F-U-N-C, which is what you save as your model name, what you assign to your model. In our own case, we have closed SEL dot. So you put it there as well. And then it takes in params, which is the name of, what you use to save your parameters. We have saved our parameter with what? Params. So I put params equals what? Params. So the arguments that ODE takes are the things I've supplied to it. And I've just explained to you how to get each of those arguments. It takes in y, it takes in times, it takes in func, and it takes in what? Params. So what should you indicate to be your y? It's your what? State variable. What should you indicate to be your times? Your time that you have saved earlier. Either you saved it as t or you saved it as time. Put it. What should you use to represent your func? The name of the model that you have saved earlier. What should you use to represent your params? The params. What you save as your parameter values. So that's just it. I want to believe majority are with me now and we can move on. Great, I'm happy to hear that, yes. So when you now run this out, you see that it just ran, right? Okay, and you are not seeing anything. So it's already there now. Please, let's pay attention. The ODE, having supplied all that it needs to solve the model, has solved it. And you have also now specified that the outcome we should put the output of the outcome as what? As data frame. As what? As data frame. So if you say view now, let's type view out. Can we just say view out? Once you say view out, it opens another tab for you and you see the outcome there. Can you see it there? What do you have here? Time, S, I, R. Are you having same thing with you? What is the error? So you should read the error message. Because you put small v now. I told you that R is case sensitive. R is case sensitive. So view there is capital V. So do you have that now? Do you have your outcome as data frame? Don't say no if you are still having the previous problem unsolved. Just put up your hand. For those people that have their own, the previous line of code that ran, they are the one I'm talking to now. If the previous line did not run, the next line cannot run. Is that okay? So if the previous line you are still struggling with it, just call for help by putting up your hand. Put up your hand, somebody comes to help you. If the previous line didn't run, the current line cannot run. So for those whose previous line, they were able to run it. Now, do you have your current line displaying your data frame? Good. View as capital V. View out. That's what you are seeing there. Are you with me? Should I go back to the code? And be sure that you're also putting comma where comma is supposed to be. Eh? What? Function? So let somebody come and help you if your view is not coming out. Some people have seen their own. You should see your own too. Uh-huh. You see your own, right? That's why you are eating watermelon because you have seen it. When if you don't see it now, you will trouble me here. When I say, are you following me? Say no. How many people have been able to get their data frame now? Great, I'm happy. I'm happy you are seeing it. Great, 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 great. Great, that's beautiful. So, others, can you please intensify effort? You will see your own too. Your own. It doesn't matter. It's bringing values, right? And you have time, SIR. It's a good one. Are we together? All right, so let's move, please. Now, from your data frame, please let's be together. So from your data frame, you would realize that this your out, you can access everything that is in there. Just put out and dollar. When you put out dollar, what do you see? You have time, you have S, you have I, and what? R, right? Is that okay? Just type out and then dollar sign, and then it will tell you all the components of the data frame. It will show out all the components. Time is there, S is there, I is there, R is there. It will show it. Actually, I don't need to do this now, just to show you that you can examine all the outputs. Okay, now I want to plot the outcomes. Now, you just hold on. Just hold on. Since you have viewed it, you have called it now. So I want to plot now. Let me just plot my outcome. All right. I want to plot time. Now I want to see my, please let's pay attention, the trajectory of my susceptible population. Is that okay? Are we together? I want to plot the outputs now. I want to be able to see the susceptible population, how that change, the population changes in time. So I am plotting out, so I put this dollar sign, time against what? Against what? Against S, right? Are we together? I want to plot time against from the output. Is that okay? From that out, the result of the what I got in the out. Are we together? So I want to plot columns of that out now. The time against S. S represents my susceptible population, isn't it? Are we together? And I want it to be, please let's pay attention. Type here signifies, when I put L, this is L not 1. Oh. L here means I want it to be line. Is that okay? I want it to be line. Then length width. This is line width. This is talking about how thick I want the line to be. You can experiment with different numbers. 1, 2, 3, 4, and see how thick it will be becoming as you use that. So the color that I want is what? Blue color. I want my X to be labeled time, and I want my Y to be labeled susceptible population, right? So because I need to enlarge my plot area so that it can show me what the output is. All right, so I will just run this. Okay, it says too large, so I have to extend it. Don't worry, I'll show you the line of code again. All right, so I have this. I have this as my okay, so I have this as my susceptible population. Yeah, I will show it again. Now, the reason I am breaking the code into the next line is so that I will be able to see it at a go. Is that okay? If you write everything on a straight line, it will be, but you may not be able to see it at a go. If something is wrong, you have to be moving, shifting the bar, for you to see it. So I have to break it to go to the next line, but it will connect. So I will not say that because you are not putting it on the same line, then so it will take it. Just put enter key. Once you get to this, just put enter key and then. All right. There's no problem. It depends on what you put. Something is wrong with your solution. Something is very wrong with it. You are putting 0.2 when you are supposed to be having 0.2. So where's the time? All right. Are you done with the code? We see typing. Let me see how many of you are still typing. Please, you have to learn to be fast because we are doing it together and we have a lot of things to do. So, how many people are still typing? Let me see. You are still typing the code. You are still typing the code. Can I see your hand? Just few persons, please. Be fast. Now, running is, do you have your plots? How many of you have your plots? You are happy, right? Are you happy? Okay. I'm happy that you are happy. If you are having a problem, please just raise up your hand. People will come and help you. I have few persons around. Please, you can become that team. Please help me. Come and join help some of these people. Okay, are we together now? If we are not together, let me see your hand. We are not together. And you see, when you hear the people who said no, because they have thick voice, you think the whole place is saying no. It's just few persons, about 2 or 3 persons that are saying no. And I've told you that if you're having any, just signify. Just signify. Somebody will come and help you. ICAMMDA team, please, if you are over wherever you are, there are few persons here who really need help. See, some people are putting up their hands there. Put up your hand if you're having any issue for somebody to come and help you. There are hands here. And we have some hands here too. Please look at your back and see hands. All right, so I would like to move on from here. Majority actually got it. So the few ones, help will come your way. Okay. So this is what you have. How many of you got this kind of thing? How many people got this kind of thing? Let me see your hand. All right. Okay, good. How many people didn't get it? You didn't get it? Oh. Joshua, you don't need to sit with some people. Just solve their problem and move to other places. Now there is an exercise I want us to do. Is somebody not helping out? Please, somebody should go to Prof, please. All right? So you'll be doing these exercises for me. So you should obtain the plot for I and R classes. Yes. I have done that of S for you. So get for I and get for R. Oh yeah, let's go there. Let's read very fast. Get for S, get for R. For I and R. The plots for S and R. So what do you do? To get for I and for R, what do you do? Eh? You can also change the color if you don't mind, right? Are we together? So if you are going to do that too, let me see who will get it. The first person to get it, I will give you something. You have gotten it. Wow. Who is the first person? I will give you kudos. Obtain the plots. Obtain the plot for I and R. You've done it. Okay, sir. Straight line. Something is wrong in how you specified your parameter values or your initial. I can see it. You can bring it up. You got straight line. You used capital letter before. You used small letter before. But you know it's not small letter that's yeah, so can I? Okay, somebody's helping out there. You should not get straight line though. Straight line like this. No, somebody got it here and I looked at what he did. I think I corrected it. Eh? You use small letter S, Abi. Sorry, it's capital you should use because you have been using capital since. Eh? The recovery is in what? Oh, it's going up, right? I love that. Okay, can we go on now? So for the question I said, I believe you have done the first one. Now let's go to the second one. I know you would. I said you should plot S, I, and R on the same graph. Yes. I want us to see, yes, on the same graph. On the same graph. With legend. With legend. All right. Now let me help you with that one. On the same graph. Now let's pay attention, please. Now, unlike now, if you see the first exercise I gave you, you are supposed to produce that with plot, isn't it? Plot, 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 isn't it? Now, because I want it to be on the same plots, I will not use plots, I'll just use lines. Is that okay? Are we together? So the same thing, I can copy the code because I just don't want to be typing. Right? And I will edit it. Lines, small l. Just look at it. But this time around, I want I, isn't it? Are we together? I want the color to change to be red. And I want this to be infectious population. Okay, so I will not, the Y lab here, I will not put Y lab. I will not put X lab. Here, that means I also have to change this one to population, for instance. Is that okay? Yes, because I want to plot three things, so this, the other one too, I'll use line again. Then this time around, R, because it's R that I want. And then I want the color to be maybe brown, for instance. Brown color. As you see that as I'm changing the color, you see the color is also is specifying the color, isn't it? So let me start running. I have this. Yes. Do you have the same thing that I have? It's not showing, isn't it? It seems not to be showing. Yes. So let me check with plots to see the values. Ah, it will not show. You know why it's not showing? The values here, look at it on the y-axis. What are you seeing there? Eh? 7. Here on the y-axis, what are you seeing there? Very, very low. So that's why it's not showing. So that means you cannot say that. It cannot because you are adding this. So you escape. Whenever you are seeing this plus, 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 plus coming, that means it's expecting something to come in. So it's not terminating the code. Is that okay? That's all I'm again. If there's something you didn't type correctly, okay. Okay. So, okay. All right. So for me, I think that we may not be able to see this one together because of the smallness of the values. Is that okay? Well, no problem. The values are small, so the values are very small. The values are very small, so that's why it's not showing. Is that okay? Eh? Your own is showing. Let me see it. Bring it. Eh? If you do I and R together, it will show. Yeah, but with S, it's not showing. Uh, if you do I and R, it will show. So let's plot I and R together. So let's do plot. That means plot here, then here what? Lines. Is that okay? So here we have to specify here that my X lab is what? Is that okay? So let's plot this. And because R is also coming larger than R, and so I can specify Y limb so that I can see can zoom in to see. Okay, so but now if I show you this kind of plot now, it's not communicating anything. You just see population, you see time. Which one is representing what? So you will have to put legend, right? All right, so let's put legend, type legend. Is that okay? What position do you want it to be? Top left, because there's space in the top left, right? Put top. So I'll put top left. Yes, top left. Is that okay? Are we together? And then to indicate the colors that I put before, I'll put that, okay, the colors, the very last one is brown, right? Brown. You specify the last one first. And then the second one, red. Is that okay? Is that okay? Then now put legend again equals to C. What is the first one representing infectious population? Right? The brown is representing, okay, let me just put the forward. Infectious. Right? And then, line type. Let me break it so that type line type 1 1 because this first I want to use the LWD, that is the line width for both of them, 2 2, and then the, don't worry, I will show you the fonts, to control fonts. Okay, good. Are we together? Now, look at it. Because I realized that the values are large and I'm not able to see them together. So I now have to plot I and what? R together so that I can see them. And how am I to do that? Plots. I'm plotting I. Is that okay? The first one here, plot plus I. And the only thing I've added here is this Y link. Is that okay? How I know that I'm supposed to put Y link is that when I plotted both of them together, I saw that R was going out of the plot. I'm not seeing it, seeing where it's ending. Is the plot code that controls what should be the limits, that the values on the y-axis. Is that okay? Since for the I is just between 0 and 0 point something, so it has created it like that. So when you now want to plot something that goes beyond that, it will just break it. But since I observe the value, the plot of R, and I know that it gets up to 2, I just say that give allowance on the y-axis to go up to what? 2. Is that okay? That's what that y limb is doing. It's allowing the plot to, the y value to go up to 2. So as to accommodate the next plot that is coming, because the next plot is having values that is more than what the first one is having. So I have to accommodate that too. That's why I put the y limb. Okay, so plotting that, just plot it and see what you have. And then when you plot line, now you will now see your R coming together, and then the legend, to put legend, because I need to be able to say that this is what this one represents, why the other one represents this. So for the legend, the argument, you have to first specify the position where you want it to be. You can know where you want it to be having plotted you have seen your plot outcome, right? You know where space is. Do you get? You know that there is space on the left, the top left. Are we together? So I just say, okay, put that legend, let the legend go to the top left, and then based on the color specified before, based on the color, so you will take it backward from the last to the first. Is that okay? Brown is the last, and then red is the second, right? And again, that brown represents the recovered class. Is that not so? And the red represents the what? The infectious class. And the line type that we use for them is this the continuous line. So the continuous line is actually having is the first one, number 1. So that means continuous line for the first one, continuous line for the second one, right? What should be the length width, the line width? I put 2. I've told you can change it and see how it comes out. And then this helps us to control the fonts, the font of the legend. If the other time I put 0.6, it was very large and it was covering the plot, I had to reduce it to 0.3, and that's when I was able to see the outcome properly. And with that, you have this. Even this is still covering, right? This is still covering the thing, so we can reduce it further. We can reduce it further, maybe 0.1. Okay, sorry. It's too tiny. We can put it 0. Just adjust it. It's too tiny. 0.2. So you can just keep increasing it to see the ones that. All right. Is that okay? Is 1. That was. Eh? Okay. You can check it. For the code, Are we done? Are we done? Who already? I have seen some people who have gotten it already. So we still typing. We still typing. Let me see if you are still typing. How many of us that we know what to do? Okay, you have gotten it. Can I see your hand? Please just encourage me now. If you have gotten it, let me see your hand. Okay, good. All right, few persons have gotten it. If you're having any issue, just signify so that somebody can come to you. Please, somebody needs help here. Okay, we need to move, honestly. Okay, your question is line type, line type, line type. This one is to control the fonts. Just try different values to see how it works with you. Yes, I've explained that. What did you use? 0 to? What are you plotting? Are you plotting? See, you should be sure of what you are doing. Are you plotting I against R? Check it. Now, if you are plotting S against another one, it will be small now. Check what you are plotting. What are you plotting? X, Y, right? This is the X axis. This represents the Y axis, right? This represents the first one X, the second one Y. So see what you are plotting against what? This is I. I'm plotting it together with what? With R. Is that what you are checking? Then it should not be big, too big, except your book is wrong. Something is wrong somewhere. Let me see. Right. Let's move forward now. Okay, your question. First line. So what part of it? Line type. Yes, and I told you that if you are using line type, you can indicate in terms of numbers. So these are things you can do for app. You can check app in R to see what are the corresponding numbers to each line type. Is that okay? I don't want to teach that. Somebody can help. Please, somebody's having issue here. All right, now the next exercise, I have to leave this point now because I actually wanted us to see, okay, I said she plot this on different graphs but on the same plot area. Look at this. Plot this on what? Different graphs but on the same plot area. Is that okay? Now, look at what I'm talking about. Imagine that. Please, let's pay attention. Can we pay attention, please? If you do this now, per, and you say m through equals to what this one will do for you is that it will make your plot area to be able to plot in terms of like matrix. Is that okay? To plot in terms of what? Like matrix. So when you run this one now, I want one row and how many columns? 3 columns. Meaning the graph will come on top of each other. Graph 1, 2, 3. But I can put 3 rows, 1 column as well. What would that be? It will be like this by the side, right? Are we together? The plot will come 1, 2, 3 by the side. Are we together? So it will help me to see all the plots at the same time. I'm not plotting them together. I just want to put it on the same plot area. So let me do 3, 1. So when I run that, it already prepares my plot area. Is that okay? So now I will have to copy this one, the 3 of them. The 3 of them that I've written before. But I will not use, I will just use plots for all of them. So I will have to increase this place so that I can have so after that, so if I do this, okay, large. I should be that this thing saying that that is too large or something. I've enlarged it. Okay, you are done. Did you get it? My own is saying that it's too large and it's refusing to give me. All right, come and show me your own. Let me just give you the code. You type it to get the. Okay. All right. You can see it now, right? Can you see it? 3 rows, 1 column, right? If I've changed it to what? To 1 row, 3 columns. This is what I would have gotten. Is that okay? Do you see the difference between the first and the second? What are you saying no for? The difference is clear now on the board. You like saying no. So you have this. Either of the two. All right, all right, all right, all right. Now, I have to stop at this point. Other questions, I will send it to you. You will do it. Yes. You will change the value of beta to 0 0.2, 0 0.4, 0.5, and then you will check. So you will put it on the platform, or maybe when you come you can display it. But we have to stop this one now. So let me show you the code for the last time. Which one are you talking about? Here, right? Okay. Eh? What? There was no error there. Now the plot area was large. I just increased it. If you're having error, it's you that's having error. Me, I was not having error. Too large is not an error now. It's just telling you that the space you have on the plot area, you didn't have enough. So enlarge it. Enlarge it. Just put your cursor there, drag it to the left and drag it up. Enlarge it and then you plot to show you. It's not as if there's error in code. All right. Please, 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 please. We need to stop this now. I was supposed to look at, please let's pay attention. I was supposed to look at how you will bring in your data, how you will, but unfortunately, all we have done today has been simulation, simulation, simulation. Just one thing. I plan to do 2 things, but I did just one. Okay, no problem. Did you get anything out of the class? Did you get anything out of the class? So no problem. We'll stop at that point. Sir? 3 comma 1, that's 3 rows, 1 colon. 3 rows, 1 colon. 3 rows, 1 colon. 1 comma 3, 1 row, 3 colons. Right? 3 comma 1 is what? No, it won't give you same thing. You should run it first. Run it first. You got it. Prof got it. I saw that reaction. All the while, when I look at Prof's face, but at least, finally, I got an excitement from her. All right, so we have to end the class now.